Hi, I'm Brittany from Grasple Support. Did you know that Grasple is a great tool for learning and practicing STEM? You may know us primarily for math and stats, but we also have a variety of functionalities that make Grasple an effective platform for STEM education. Let's hop over to the Grasple platform to take a look at some examples. Now that we're on the Grasple platform, let's take a look at some exercises that really show off Grasple's STEM capabilities. We're going to start with this gravity exercise. The first cool thing that I wanted to show you about working with Grasple for STEM education is that we utilize something called parameters, which means that the values, like this one here, can change each time the question is loaded in. So right now we're working with 500 kilograms, but if we choose a random parameter set, we see that that number changes. Now it's 750, random again, to 400. And that's really helpful for making sure that the students understand the logic behind the calculations and don't just, memorize a question so that they know how to answer it, and only when those values are there. So back in the student view, we see that we have been generated the value of 450 kilograms. One feature that makes Grasple great specifically for STEM questions is the use of unit. You can express the answer to this question in a variety of formats. And the cool thing about Grasple is that it will accept all of the formats. We can express this as in newtons, and Grasple will show us that newtons is correct. The other thing that we could do is we could express this in an equivalent unit. So in our case, we'll use kilogram meters over seconds squared. And as you can see, Grasple understands that these are algebraically equivalent and tells us that this answer is also correct, even though we've used a different unit than was specified, or than, perhaps the professor may have expected. On the other side of that coin, however, we can also specify which unit we'd like to use. So to calculate this one, we have the same value. Now the teacher has asked that this value be expressed in kilogram meters over seconds squared. As we know, that's equivalent to a newton, but if I check the answer, it says this is incorrect. Here you must report the mass in kilograms over seconds squared. If we try again, and this time include the correct unit, we see that the answer is deemed correct. Now that we've taken a look at some examples of questions that accept equivalent units and do not accept equivalent units, let's take a look at another set of example questions. This time we're going to take a look at kinetic energy. Another great Grasple feature that exists not only for STEM education, but for all of the exercises on Grasple is that we offer something called sub-questions. So here we're going to be asked to calculate a value, and then we're going to use that value, after we've been told whether it's right or wrong, to tackle the second part of the question. This is great for breaking down more complex topics into smaller bits that students can tackle more easily in a step-by-step way that allows them to practice step-by-step problem solving. On to this specific question. So as I said, we're going to start with one calculation that's then going to inform the second calculation. Here we're also using parameters, and we could cycle through another set, a different value if we wanted, but let's just stick with the 4 kilograms for now. A ball with a mass of 4 kilograms is thrown at a velocity of 20 meters per second. What is the kinetic energy of this ball in joules? So let's do the calculation here. So if we do that calculation, we get 800 joules. As we can see, the teacher has specified that the answer should be given with the unit in joules. So if we check this answer, we see that it's correct. But if we try again and use a different unit value, we can see that we actually get some personalized feedback telling us that it has to be in joules. It also gives us the formula to calculate this. So the idea is that students can see the correct answer, understand where they may have gone wrong in their attempt, and they can learn from that mistake and improve their score going forward. So, as we already established, we have 800 joules. This is the correct answer. Now, we now have a sub-question that's related to the first value. So now suppose the ball loses 50% of its velocity due to air drag. What is the new kinetic energy? Give the answer in joules with a precision of 4 digits. This also highlights another useful feature in Grasple, that being the precision. So here we can say that the final value must have 4 digits. If it has 3, it will be marked incorrect. If it has 5, it will be marked incorrect. It needs to have 4 digits specifically. So if we do the calculation for this one, we get a nice even number of 200 joules. So we may be tempted to just input that answer. However, remember that the precision is of 4 digits. We can try this question again, and a nice 0.0 to ensure that we have the correct precision. And there you have it, a quick run through of all of Grasple's STEM capabilities. As you can see, Grasple's sub-question, personalized feedback, and parameters features, paired with the STEM-specific features like unit equivalencies, non-equivalencies, and precisions, make Grasple a powerful tool for STEM education. If you'd like to experiment with the example STEM questions you've seen today, please send us an email at hello@grasple.com or visit our website. Thanks so much for watching, and happy Graspling.